Hello everyone, welcome back to Practical Serverless and Microservices with C Sharp. My name is Muhammad Abdullah and I am Microsoft Certified Azure Solution Architect. So for this course, this is our agenda to understand the serverless microservices on your architecture, Docker, different type of Azure function, background function, IoT function, and microservices practically, and then Kubernetes, how to work with containers and Azure Container App. Then we will check the security observability for serverless and microservices application. For the whole course, we will focus on the car sharing microservices project. And lastly, we will see the microservices with .NET Aspire. So this is our agenda for this course. If you missed the previous sessions, so please check out the previous sessions. So in this session, session number 6, Azure function, we will discuss the Azure function and different trigger of Azure function. So before I start the session, this course is moving from the theory to serverless and microservices to a practical implementation of Azure function. So in this course, our total focus is to, beside the theory, we will totally focus on the practical work. So to explore and implement different triggers available in this Azure function. This is our agenda for this session. We will explore the triggers, different triggers like HTTP trigger, SQL trigger, Cosmos trigger, and Azure bus trigger. So we will see this practically with the help of Visual Studio and Azure portal. So the first one is the Azure trigger. So this is the what is the basic of Azure HTTP trigger. So this is the most common trigger in Azure function. It allows a function to execute in response of HTTP request. So the use cases for this trigger is building APIs, creating webhooks, developing integration. So the core principle, a function method is triggered as soon as HTTP request is received. Whenever the function receives any HTTP request, it responds accordingly. So this is the simplest version of HTTP triggers. So this is the what is the advantages. It's easy to use, and it also support the get, put, and delete HTTP methods. And it's also a microservices friendly, and integration, we can easily integrate this with other Azure services and third-party library, and it's also a scalable and cost-effective. So the disadvantages, it has the cold start latency, like there will be a delay on the first request. Whenever you hit the first request, there will be some delay, and this is the drawback of this HTTP request. And the other one is the stateless nature. This HTTP trigger has a stateless, like for example, if you have stateful long running process that need the state to be saved. For this, this is not suitable HTTP trigger. So instead of HTTP trigger, we use the Azure durable functions. So we will discuss Azure durable function in the upcoming lessons. And it's a resource limited function, have limited on execution time and memory. Exceeded these often point to a design issue. So this is some drawbacks of HTTP triggers. And when you design HTTP trigger, there is some authorization level, like HTTP trigger allow for different level of security using authorization key. Like we have anonymous that need no access key, and we have function or function specific key is required. And the other one is the admin that need a master key. For example, if you go to Azure portal and open the app function app keys, you will see the master and the default key. So you will need this key to be work with HTTP triggers. So few questions like when to use HTTP trigger. So this is very common question, like when you will use the HTTP trigger. Use HTTP trigger for lightweight stateless function that respond directly on the web request. For example, if you have a REST API, you can use the HTTP trigger. Webhook handle real-time notification integration, like driving a connection between the different services, and you can also use in case of prototyping. So this is some use cases. Now we'll go back to the actual code of the HTTP. So we will focus on one scenario, like as I share this in start that we will use the car sharing microservices in this project. So this is the part of the HTTP trigger, a car sharing application with a car holding API that use the Azure function. So we will see this in action. This is the one solution, and it has different triggers. So the first trigger is the HTTP trigger. So I created this Azure function based on a HTTP trigger. So you can see here this trigger, this app has different type of functions like create, read, and update. Then we have delete. So this is for CRUD operations, CRUD functions. So this is for Swagger OpenAI setting, and this is important like the HTTP trigger. This is the Azure function based on HTTP trigger, and this is the Azure. I already discussed like HTTP trigger has three type of authorization like admin, function, and anonymous. So this is the Azure function level, and it's about post, and this is the root of this application. Okay, so it receive the HTTP request and it process the HTTP request based on our requirements. So currently there is no implementation, actual implementation, just we are logging some information. So this is the create. Similarly, we have read, update, and delete with same authorization level, and each have their type, delete, then read and create. So to run this, we have some information like we have configuration for this. This is the configuration OpenAPI configuration file, and we have app setting.json file, and we have services dependency.json, and apart from that there is no other and similarly we can also have this we can also configure the connected services to this configuration this Azure function as well, but there is no currently there is no such thing. So just to show you how HTTP trigger works. So I will run this in front of you. So I select car holding as a startup project, so it will run. So you can see here it's now running, and you can see here we have create, delete, read operations, and this is the link of the Swagger. So this is the Swagger UI, and we have different post get, put, and delete method. For example, if I want to test this read one, it's simply returning the information. So this is about how practically look like the HTTP trigger. Okay, so okay, so implementation, I already shared the implementation with you. The simple code provide for HTTP trigger function to handle standard CRUD operations, and you can also, I will share the source code with this course as well, so you can check out the code as well. So the next trigger is Azure SQL Trigger. So the basic of Azure SQL Trigger is a function trigger that is invoked as soon as any change happens in the SQL database. For example, insert, update, delete. So the key requirement, this trigger requires SQL Server change tracking to be enabled on the database, and specifically on the table side. So I will show you this. So you will on the tracking for the database and a table side to get advantage of the SQL trigger. So the purpose, enable real-time data processing and integration based on database changes. Whenever anything happens in the database, any table, so you can trigger this this Azure function. So it used for real-time processing, scalability, and cost efficient. Provide the same benefit as the Azure function by scaling only when needed, and it being cost effective. And integration, great for integrating different applications based on the database events. So disadvantage is a little bit complex in setup, and latency. You must consider potential latency issue, and design. You need to decide if this trigger is a better solution than a simpler option like a timer trigger. So this is about your requirements. So you will decide based on your requirement. It's suitable, SQL trigger is suitable, or timer trigger is suitable for you. And example audit changes. So I will show you the SQL trigger based example in Visual Studio, but for this you will need to create one SQL Server database. For example, in my case, I will go with car sharing DB, and you will create one table, car holding in my case, and you will enable. I will also give you a script to enable tracking, and you will also allow IP if you have a SQL Server. So you will also allow the IP as well, or Azure portal, and I created one specific resource for this course. So you can see here I already created one SQL server, and the other one is the database. So these two things is needed. First you will create SQL server, and how you will create, I will show you. Like for example, you will go to the home page, you will search SQL server, and you will click on the create, and you will select the subscription, then resource group you are using, and you will give any name to a server, and you will careful while selecting the package. Like for example, I will select with SQL server authentication. You will give password and confirm password, and you will go to the network security. You will keep it default, And you can see here I will go with the, I will not use Microsoft Defender for now, and you will give the name, and you will create. So this is how you can create. After creating a SQL server, you will add the database, SQL database. So you will go to the database section, you will create the database, and here you will select the database name, you will select the server you create it, and you will select the, if you are using SQL Elastic Pool. So I'm not using, so click no, and it's for development purpose. And you will select local redundance, just for this is just for the learning purpose, so I will go with local redundant. And this is the storage and compute. So I will go, so you will select the basic version just for the development purpose. So you will be careful here while selecting the workload for your application. So once you create the SQL server, you can open this in the SQL management, SQL server management. So you can see here I already created, and I'm connected with the this server. So how you will get the connection string? So you will go to the your resource group, and this is our server, and you can see here you will go to the, this is the name of the server, and now I will go to the database. So this is my database, and this is the connection string. So you can get connection string from this part. So this is done. Now you will connect with the server, and you will change the database. So this is our database, car share DB. So what I'm doing with this script, I'm just set change tracking on. So you will need this to be on for this database, and you will also create a table. Okay, so this is two things. You will enable tracking on the table side as well as on the DB side. So you will need this script to be run. So once you run this script, the tracking will be enabled for this. Now I will go back to the Visual Studio. Now I will run the other part, like for example this is the this Azure function is based on like SQL triggers. You can see here this is Azure function, and it's based on the SQL trigger, and it's accepting, this is the car holder, this is the table name, and this is the connection string, and it will accept the list of the read-only SQL changes. So this is the changes list, and you can process the changes according to your requirements. And for this you will add this local setting .json, and you will need this property to be added, website site name, which is the audit app. And apart from that, if you go to the connected services, you can see here you will connect the SQL database here. So you can see here you can connect. I already created the car share DB, so you can also edit. For example, you can select your database from your subscription as well. For example, this is our database I created on the Azure portal. So you will select this, and you will go next, and then it will be connected to your Visual Studio and this Azure Service app. And you can also manage the secret in this secret.json file as well. So if I go to the manage secret session, this is the connection string I will get from the portal. But I already show this. You can see this database, and you will get this. Okay, so this is about the SQL trigger Azure function, and I will go back to the audit. So you can see here I will run this application. Let's go select as a startup project. So now I will run this application. Okay, so now it's running, the application is running. Now I will add one data. For example, I will insert one record to the table. For example, ID 4, and this is the Abdullah. So I will add one record. As soon as I add the record, I will select the database to run the query. Okay, so record is inserted, and you can see here it's triggered, and I will run, and you can see here this is the record is added, the new record is added. So you can see here this is how the Azure function, you can see here this is the SQL changes, operation 0 item, this item is added. So this is how the SQL trigger Azure function work. I give the whole changes, how you will do the all changes required for this function. Okay, next we will see the Cosmos DB trigger. So it's a powerful feature that allow serverless function to be executed in response of to any change in your Cosmos DB changes. Whenever you add any data to the Cosmos DB, you can trigger this Azure function, and the trigger is invoked automatically when item is added, updated, or deleted in DB collection. And it's also enable real-time data processing and integration similar to a SQL Trigger. And it's data flexibility as well. Cosmos DB offer more flexible for handling non-structured data. So SQL Trigger is used for the relational data, and this one is not non-structured data, make it ideal for type of data that would be difficult to handle in a relational database such as car telemetry data. So this is some advantages: real-time processing, data flexibility. So it's like for the non-structured data we can use this, so it will be a flexible option. And the one of the disadvantages is that it's very expensive, so it's crucial to carefully consider the cost of the solution when you are developing. So this is example car telemetry. So there is one scenario: a car sharing app use Cosmos DB for high performance globally distributed storage of real-time car telemetry data such as user activity log, location. So for this, for development and testing, we can create a new Cosmos DB trigger in Visual Studio, and we can also set up the local setting as well for debugging and testing, like we can use the Cosmos DB emulator as well. This is the example of the Cosmos DB trigger. So this is the code. There is one function, Cosmos DB trigger, and this is the database name, container name, DB connection, and the lease container name. It's also used for a container used to manage leases for processing changes. So this is the simple trigger, Cosmos DB trigger. So first you have like a few options. So you can use the emulator. So you will install the emulator from, for example, if you go to this link, microsoft.com, you can see here what is the Azure Cosmos DB emulator. So you can download, when you go down, you can download the emulator as from this page. So I already installed. Another option is you can also use the Docker option as well. So you can install, you can get the image of this emulator, DB emulator, and for both Linux and Windows. So it will provide you image as well. And if you go to with the emulator desktop application, so you can see here I already installed the Azure Cosmos DB emulator. So when you launch the emulator, you will see something like that. So you can see here it will run on this local host 8081, and it's the Explorer, and this is the index page. So to save this cost, I will suggest use this emulator, and it will perfectly work as like a real Azure Cosmos DB. So first of all, according to the code, this is the code. So first I will need some connection string. So you will need the Cosmos DB connection string. So from where you will get this connection string, once you run the emulator, when you go to the quick start page, you will see this primary connection string. So you will copy and you will paste this in your code. So this will be the connection string. And the second thing is the code, actually the code. So this is the database name. So you will create one database and one container with the same name you mentioned in your function. So when you go to the Explorer, you will click on the container and you will give the name. For example, in my case, I have this will be the database, and the container ID will be, this is the container ID, and this is the partition key. So the partition key will be like the car slash ID in our case. So I already created. You will click on the OK, and once you create it, you will see this item in the list. So I'm the container, and this is all the list we have in the this item list. So this is the item list. Okay. So this is the program, and now I will run this application. You will make this as a startup project, and now I will run. And this container, it will if this is exist, it will not create it. If this is not there, it will create the list. For example, this, you can see here, this is the extra container created if this is not there. And it will also accept the input, like what changes made in the Cosmos DB. It will accept all as an input. And this is the object, like we have car ID, we will receive the car ID, and we will print out the car ID, and this is the modification count, input.count. So you will bind this read only list with this class. So now I will run. So now the function is now running. Now it will track all the changes happening in the emulator. So now I will go to this emulator and I will add one other item. But for before this, this is our data, sample data, and this is for example car number 5. Okay, so this is the same. We will keep this date and data same as it is. So I will save. Now I will go back to the emulator. Now you will click on the item, new item. So this is the item list. Now I will go to the item upload. Now I will select the data file. I already have a data file and I select it. Now I will upload. So it's uploaded. Now I will check the log. So you can see it's the trigger is now hitting, and if I go one, you can see here the input count is 1 and it's getting one item. Okay, you can see here this is the same data we are passing from the file. So now you can see here this is the data changed in the one item is first item car. You can see here this is the same car ID I am passing from the file. So this is how the Cosmos DB work. And there is one important distinction, a critical difference from the SQL trigger is that the Cosmos DB trigger only monitor insert and update, not the other case like the delete. No deletion case. This trigger does not monitor deletion event. If you need to track deletion, you will need to implement alternative solution. So this is one of the important distinction. So now we will discuss the Azure Service Bus trigger. A serverless function is triggered by messages in Azure Service Bus, a powerful message broker. It's a message broker for microservices communication. So we will see this in detail. So a Azure Service Bus have two model. One is quiz and the other one is the topic. The quiz one-to-one relationship where a single receiver processes each request. They ensure reliable order delivery and are great for decoupling application and buffering messages. So we will see this in practically. And the other one is the topics, which work on the publisher subscriber pattern. It handle one-to-many relationship where a single message can be delivered by multiple subscriber. They are used for complex workflow where different services need to be react to same event. And the topic can also be filtered to route specific messages to for the specific subscriber. So if I go to the portal, you can see here this is our resource, and I created this resource for this course, and here you can see here I have one is a service bus namespace called car share service bus. When I open this service bus, you can see here this we have entity, we have quiz and topic. So this is the two model I'm talking in this slide. So we have two one-to-one relationship, and the other one is work on the one-to-many publisher subscriber patterns. And this is the next slide is Azure Service Bus Trigger. Benefit, it's a reliable, secure, and we can do integration easily. It's very flexible, and about the cost queue are generally cheaper than the topic. So we will see this as well. The topic, if you want to use the queue only, so you can use the basic with basic subscription as well. But if you want to do both the queue and the topic, you will need a extended and premium package. You cannot do a topic with the free version. So choose the model that fit for your need to manage the cost. And next is the apart from the Azure service, we can use the other option as well, like Kafka and RabbitMQ. If you are working inside the Azure environment, so the Azure Service Bus is a great choice. And if you have like massive amount of data, like data streams, so you can use the Kafka, and you can also use the RabbitMQ, and it's easy to use and highly flexible, and it's a lightweight, and it make very versatile options as well. So this is some other option you can consider while working with the messages bus, message broker. And in our code example, we have one scenario when a user search for a car, a message is sent to a service bus topic named car seeker request. Like the purpose of the topic, a topic used because multiple microservices like the route planner, the notification service, and need to react to the same cars, the same event. So For this we will create the dedicated Azure function to monitor. So if I go to the code, Visual Studio, there is one Azure function, route planner, and we have one car seeking class, and we have one function, and you can see here that this is the SQL based trigger, and this is the topic, this is the topic, and the other one is the subscription name. We will see this topic and subscription name from where you can get this. And this is the messages. You can receive the messages. For example, I'm receiving this message, and I'm getting the message and ID, message body, and message content. And the other one is the service bus message action. Whenever it mark the message, like when it's successfully processed, it remove from the queue. So this is needed to complete the message. And you will go to the we will go to the Azure portal. So this is our resource, and here I created one. You will create one Azure bus, and you will create, once you create, you will have these two model. So for this example, I will use the topic because the subscriber will be multiple in our case, so I will use this. So the first thing, you will create one topic. So you will give name to the topic. So for in our case, we have a car seeking request according to our code. You can see here, this is the topic name, so I will use the same topic name in the portal as well while creating the topic. You will just give name and hit the create, so you will see this in the list. Once you have this in the list, you will click, and you will create one subscriber. You can see here on the left side, I have one entity subscription, and you can see here I have only a route subscription. If I go to the code, I have a route, and you will create subscription, you will give name, and you will see you will just give name and create. So but I already have created and the subscription, so I will not create it again. So now the other thing, you will use the Explorer to send a message. For example, this is our Azure function. Here is the local app setting. This is the connection string of the car share bus. So you can get this from the you will go to the, when you create the bus, you will get this connection. So you can see here in the left side, I have setting. Under setting, we have share access policy, and this is the default route. And when you click, you will get the connection string. So you will get this primary connection string. This is needed, and you will put it in this setting. So once you get, you can now run the application. Now I will run the route planner. So now it's run, car seeker is run. Now I will send one message from the portal. You can use other tool as well to send a message, like you can create the C# console application, and for now I will use the same Azure portal. So now I will go to the topic, and I will click on the topic. Now you can see on the left side, you can see the Service Bus Explorer. Now I will click the Explorer. And now you can see here the send message option here. So I will click, and here I will write some message. Service Bus Explorer. So now I will send. Sending completed. Now you can see here it's automatically triggered, and we can get all the information inside the message. So this is the message ID, the message body, hello from the Service Bus Explorer, and this is all about the how you can receive the information. So this is all about, you can see here, this is all the information, the message ID, body, and this is the end of this session. I have one question for you. What are the benefit and concern associated with using Cosmos DB trigger in the Azure Functions? So this is your assignment. So see you in the next video. Thank you.